Hi Chem Peeps, this is the last video in the series for electron configurations, but we're going to talk about quantum numbers today. And that seems pretty complicated, but it really isn't. It's pretty easy once you catch on. I always tell my students quantum numbers are kind of like an address. Like if I was going to send you snail mail to your home, I would have your name, I'd have your street, I'd have your town, I'd have your zip. And that letter that I'm addressing to you would get exactly to you. There's no one else in the world that has the same 4 quantum numbers or 4 address pieces in your mail. And so electrons are the same way. In an atom, every electron found in that atom has its own unique address. And basically you have to learn the 4 numbers. And once you know what the 4 numbers are and what they represent, it's pretty easy to nail down the quantum numbers for an electron. So let's look at the notes that I have here. The notes that I have here explain the 4 numbers. We represent the numbers with letters. I know, it could be a little more confusing. So we have a quantum number represented by N, a quantum number represented by L, M, and S. Now what do each of these mean? Just like your snail mail address has a name, a street, a town, and a zip, the electrons also have 4 numbers that nail down where they're found in an atom. The principal quantum number, represented by the letter N, tells us the energy level. Right now in the periodic table, we have 7 rows, which correspond to 7 energy levels. It's basically how far away from the nucleus an electron is found. So 1 through 7 represents the quantum number N. Azimuthal, that's a mouthful, L represents the shape of the cloud. And so right now we have enough electrons in the atoms to have 4 clouds. S, P, D, and F are the 4 clouds, and we give them numbers. So S is represented by 0, D is represented by 1, or P is represented by 1, sorry about that. D is represented by 2, and F is found as, I always do that, don't I? S is represented by the number 3, okay? Now, we go to the quantum number, magnetic quantum number M, and it represents the orbital position. In other words, think of each cloud having seats that the electrons are sitting in, and those seats are numbered. And so in the S cloud, we know that, let me get my pen here. In the S cloud, we can have 2 electrons, and in the clouds, we represent those seats with boxes. And so we know the S cloud can hold 2 electrons, and we're going to represent each electron with an arrow. So I'm going to have one pointing up and one pointing down, and that just kind of represents their spin. Electrons rotate or spin on their axis, and they rotate opposite to each other to reduce repulsion energy. Because there's only 1 box in the S, we number that box 0. Okay, so let's look at P. We know the P can hold 6 electrons, therefore there's 3 seats. Okay, and so I'm going to put 3 electrons in, spinning positively, and 3 spinning negatively. And so if I number these boxes, the center box is always 0. So the M value is 0. And then I number out like a number line. So the box to the right is a +1, and the box to the left is a -1. The D can hold 10 electrons, so that means there's 5 boxes. And again, I'm going to number the center box 0, number out positively to the right. So this is +1, and this is +2. And then to the left, it's -1, -2. And then the F cloud, we know, can hold 14 electrons, so that means there are 7 boxes. And so the center box is going to be 0, number out like a number line, +1, +2, +3, -1, -2, -3. So these numbers under the boxes represent the quantum number, magnetic quantum number M. Okay. Finally, the spin is whether the electron is pointed up or it's pointed down. If it's pointed up, it's a +1/2. If it's pointed down, it's a -1/2. So these 4 numbers, N, L, M, and S, represent the quantum numbers. Let's do an example using the 4 quantum numbers. Okay, I have an example here with the boxes showing the up and down arrows representing electrons. There are 7 electrons across here. We have filled the 1s, the 2s, and half filled the 2p. I've circled the electrons that I want to focus on. So let's look at the first one that I have here. It is found in the 1s box. It is in energy level 1. So N is going to be a 1. I know that because of the 1 out in front. Now, this electron is found in the S cloud. The S cloud has a 0 symbol, so I'm going to say 0. So I'm in the first energy level, S cloud. Now, when we number the boxes, we are going to give the center box the 0, and then I am going to number out. But there's only one box here, and so this is a 0 box, so I'm going to say 0. The arrow is pointing down, so it's going to be -1/2. Okay, so the quantum numbers for this first circled electron is 1, 0, 0, -1/2. Let's look at the second electron here. It's found in the 2s cloud. So energy level 2 is going to be N. N is the energy level. L is the cloud number. It's an S again, so S is 0. All right. M is the box number. Well, there's only one box for S, so it's 0. But this time, the arrow is pointing up, so it's +1/2. So the 4 quantum numbers for the second electron circled here is 2, 0, 0, +1/2. Let's look at the third electron here. It's found in the 2p. Again, it's found in energy level 2, so N is 2 for the principal quantum number, but it's found in the p electron cloud. So p has a symbol of 1. We have to number the boxes. The center box is always 0. Then we number out, so to the right is +1 and to the left is -1. It is found in the -1 box, so it is -1. And it's pointed up, so it's +1/2. So the 4 quantum numbers for the third circled electron is 2, 1, -1, +1/2. Let's look at the last electron circled here. It again is also found in the 2p, so it's going to be energy level 2. The P cloud is symbolized by 1. M is going to be the +1 this time, and it's pointed up, so it's +1/2. And that is what quantum numbers are. I hope this helps you. You can find more information on my channels, ChemChat, on TikTok and YouTube.